Hello learners and viewers across the globe. I welcome you to the Legends Educational Consult Virtual Classroom. On integrated science, I'm taking you on an aspect of chemistry, an intriguing topic, which is electronic configuration. Let's quickly go back to refresh our memories on atomic structure and atomic particles, where we came to appreciate that an atom has three subatomic particles, which are protons, neutrons, and electrons, with proton having a positive charge, neutron being neutral, and electron having a negative charge. We came to also appreciate that inside the nucleus of an atom is where we have our protons and neutrons. Don't forget, the nucleus is the centrally placed or positioned organ. Now, around the nucleus, we said is an orbit or a shell, and on the shell we have electrons. So the electrons orbit on the shell or moves around the shell. Now, today we are looking at electronic configuration, and we can define electronic configuration as the arrangement of the electrons of an atom or an element on its orbit. How would I know the electrons? It depends on the atomic number of the element. And from our previous lecture, we came to understand that we have a special table that contains the elements. And on the table, we looked at the first 20 elements, that is from hydrogen to calcium. The number or the atomic number of the element determines the number of electrons it possesses. Saying so, we will understand that hydrogen is the first element on the periodic table, hence has electron number 1 or has a single electron. Calcium is the 20th element, and that means it possesses 20 good electrons. Now, looking at this number of electrons, we must carefully arrange them on its path or on its orbit, and following guidelines to be able to arrange the electrons on the orbit is what we call electronic configuration. These electrons are arranged on shells or orbits. We have K, L, M, N, O, and that shells. K is the first shell, second is L, third is M, N is the fourth shell, and O is the fifth shell, in that order. For the purpose of this particular lecture, we are looking at how we will be able to draw the electronic configuration for the first 20 elements of the periodic table. And with that, we are going to concentrate on the first 2 fourth shells, the K, L, M, and N shell. How do I identify that this is the first shell? The shell that is closest to the nucleus is the first shell. So when you look at the atomic structure, counting the number of rings around the nucleus, the first is the one closest to the nucleus in that order. So we have this structure. Good. We have K, L, M, and N, with the central organ being the nucleus. And the number of electrons this shell can contain depends on the energy level of the shell. But there is one thing to note, that the energy level is less when the shell is closer to the nucleus. This means that as we move away from the nucleus, a shell increases its energy level. Therefore, K shell would have the less energy level and progression in that order. Now, how would we determine the number of electrons a shell can contain? We will simply apply a formula, and that is 2 into bracket n squared, where n is the shell number. We said from the nucleus, the closest is the first shell, second, third, and fourth. And so K is 1, L is 2, M is 3, and N is 4. So if you want to know the number of electrons each of these shells can contain, then we apply this formula, 2 into bracket n squared. Now let's prove the formula. We have K, L, M, and N. K being the first. So we said when we see N, we put the number there. So 1, 2, 3, and 4. So the formula gives us 2 into bracket 2, 1 squared for the K shell. We have 2 into bracket 2 squared for L, and 2 into bracket 3 squared, with the last one 2 into bracket 4 shell squared. If you want to go further, you can add O, 2 into bracket 5 squared. Let's expand this mathematically to know the number of electrons each of the shells can contain. K gives us 1 squared, which is 1, so we have 2 times 1, and that is giving us 2. 2 squared will give us 4, which will give us 2 by 4, and that we are going to get 8. 3 squared is giving us 9, therefore we have 2 by 9, and that gives us 18. We have 4 squared is 16, so we have 2 times 16, and that gives us 32. I wish you solved the last one for your own per usual. Let's focus on the first 4 for the first 20 elements. But rightly, if you do it, you are going to have 50 maximum number of electrons. So this means that K shell can contain 2 electrons, L contains 8, M contains 18, N 32, and O 50 in that regard. But for the first 20 elements, there is this rule that says that all elements that are below 20 has a maximum number of 8 aside the first shell. Saying this, it means that our K shell can contain 2 electrons, L contains 8 maximum, M 8, and N 8. I look forward to explaining this part into detail in a different lecture. So we have the understanding that for the first 20 elements, the first shell can contain a maximum of 2 electrons, the second shell containing 8, the third shell 8, and the fourth shell 8. But let's understand, until the first shell is full, you can never start filling the second shell. Until the first and the second shell are full, you cannot start filling the third shell. And you cannot skip a particular shell to fill the preceding shell. Let's look at some examples. So we have come to understand that the atomic number of the element determines the number of electrons it has. Therefore, examples. Hydrogen is the first element on the periodic table, so it has electron number 1. Therefore, on K, L, M, N shell, because it has only 1 electron, we place the 1 on the K shell and the others will have none. If it has no electron, you don't waste time drawing it. So this will be the configuration. Always don't forget to indicate the central organ, which is the nucleus. So we have the K shell and a single electron, and this represents the electronic configuration for hydrogen. Let's look at the second one, which is helium. Helium has only 2 electrons, so we place all the 2 on the K shell, and that is it. Drawing the configuration, we have the K shell, the central organ, and 2 electrons. This is the structure or the configuration for helium. Let's look at more examples. So boron is the 5th element. So we have 2 on the K shell, remember 3. The 3 goes to the second shell, that is the L shell. And you know the L shell can take a maximum of 8. It has 3. So you don't divide them and spread them on the other shells. Until the second shell is full, you cannot jump to the 3rd or the 4th. So the configuration is 2-3, meaning it will have 2 shells, with the first shell containing 2 electrons and the second shell containing 3 electrons. Always don't forget your central organ, which is the nucleus. So boron has this configuration 2 and 3. What about neon? Neon has 10 electrons. Therefore, the first shell is taking 2, remainder 8. We put all the 8 on the second shell, which is L, and that is the maximum number of electrons it can contain. So we draw the configuration for neon. Our central organ, the nucleus indicated. So we have 2 electrons here. We have 8 on the L shell, and that is the electronic configuration for neon. Now let's look at this table. So I have the elements here, my electronic shell K, L, M, and N shells. Good. This indicates that hydrogen with 1 will fill the first shell, which is K. Helium has 2 and it will fill the shell K2. Lithium is 3, so we put 2 on the first shell. The remainder 1 comes to the second shell. We can do that for all others. Barium is 4, so we put 2 on the K shell. The remainder 2 goes to the L shell. So we have it as this. Boron 3, as we realize here. So we have boron is 5, so it has 3 on the outermost shell, that is the L shell. This is neon 10, so we have 2 and remainder 8 on the second. Now sodium is 11, 2 on the K shell, 8 on the second shell. 2 plus 8 gives us 10. We still have a remainder 1 electron. Therefore, once the second shell is full, that one will be placed on the next shell, which is the M shell. Magnesium 2, similar. 2, 8, remainder 2. The 2 is placed on the next shell. Aluminium 2 follows the same. Silicon 2, 8, and 4. Now we have argon, which is 18. So the first shell takes 2, the second takes 8, and the last 8. That gives us 18. Any other element beyond that, the electron, the excess, would move to the preceding shell, which is the N shell. So we have 2, 8, 8, 1. Let's add them. 2 plus 8 gives us 10, plus 8, 18, plus 1 gives us 19. So we are talking about the element potassium, which has 19 electrons. Then calcium will give us 2, 8, 8, 2. So to say, it means that for the first 20 elements, the outermost shell that an element can have can never go beyond the N shell. And the innermost, rightly, is the K shell. With this, we can draw the configuration for all the first 20 elements. I hope you find this very useful. Try to follow our page on Facebook, DLEC Educational Consult, on YouTube channel, subscribe and share to everybody. I think a student or a learner will be blessed. Thank you.